Okay, welcome to 10.9. The notes that we have in Canvas, if you're using them right now, okay, it is the 10.9 and 10.10 notes. So it's not this super long thing, okay? We're just going to do the first part of this today, and tomorrow we will talk about the rest of it, okay? So for 10.9, all we're doing today is we're learning how to graph a circle. We're learning how to graph a circle. This is your time to do something easy, like graph a circle. You'll figure out it pretty quickly. It's pretty easy, okay? And then you can use this time to catch up on all the stuff that we've been missing, all right? Because I know it's winter time, right? Everybody's out for all kinds of sports and stuff. So this is a good chance. This is a good chance for you to go ahead and catch up, ask questions in class, okay? So here's what we're going to do. We're going to start off today with recall. What is the definition of a circle? So if we turned our notes, and I can't physically do this because I'm on an iPad, but if we turned our notes all the way back to the very first day, we defined a circle as our first term. It was the first thing we ever did, right? We decided on a definition. You guys remember me being like, how could you give me instructions, right? I think I said this exactly. How could you give me instructions so that I can make a circle every time, okay? And this is what you guys said. You said first you pick a point. Okay, so first you pick a point. All right. The circle is the collection of points that are all equidistant from that point. So then we said, well, the circle is all the points equidistant from that point. Equidistant from that point. Now think about what this means literally, okay? I know in our heads it means, oh, it's a line, right? In here, in terms of mathematics, what I'm thinking is, and you don't have to do this picture, but we're just thinking about it. Okay, if you picked this point on a graph, xy, right? If this was an xy graph, okay? If you picked this point, whatever it is, and then you picked a distance r, okay? Then you go away. All of the points that make up r, let me draw instead like this. All of the points that are the same distance away from the center point are included in the circle, and so that's how you end up creating this circle, okay? So, as we move on, we'll talk about this more, okay? But think about this idea as we're continuing, okay? So, using the definition of a circle, draw a circle with center 2, with a center of 2, comma 2, and a radius of 1. Okay, first of all, ordered pair recap, right? Ordered pair recap. We all know how to do this, okay, from Algebra 1, all right? I'm going to go over 2. 1, 2. Not that bad, right? I'm going to go up 2. 1, 2. Here is my center. Here's my center. This is the center of my circle. Okay, I'm going to draw a point here, and we all know, right? I'm just going slow today. No, we're recapping. This is my center, 2, comma 2. This is the middle of the circle. This is what I'm declaring. In the definition, this is the point I'm picking. This is the point I'm picking. I encourage you to try and do the next step alone, okay? I want a radius of 1. I want a radius of 1. I'm going to pick all of the points that are exactly the distance 1 from the circle. Here's a point that's distance 1. Okay? Here's a point that's distance 1 right there. Okay? Here's a point that's distance 1 right there. And we don't have to do this everywhere, right? We see that this is a distance 1 away. Okay, this point, a blue point, is the distance 1 away. Okay, if we keep this up, this is the distance 1 away. This is the distance 1 away. I could sit here and draw points forever. There's about a distance 1 away. There's about a distance 1 away, right? We could do this forever. We could keep doing this forever and ever, right? Why don't we just pretend, after we've picking all these points that are distance 1 away, why don't we just pretend we're drawing a line? We just pretend we're picking all these points. Ooh, that is so bad. We just pretend we're picking all these points by drawing. Oh my lord. By drawing a line, okay? So I'm saying, it's just like, on the y equals x, really we're saying it's a point. On any graph, we're saying it's a collection of points, right? But we're drawing it as a line because it's infinitely many points crammed together. I'm going to try a third time to draw a decent circle. I just can't. I can't do it. It's unfathomable. The circle drawing skills have left me. Look at this. 5th try. We're going to keep going. There it is. That's pretty good. Okay, that's pretty good. We'll keep that. And we'll just erase this guy, this point. Okay, so now all we have is we have the collection of points. In blue here, I'm going to point at this. This is literally the collection of points. Okay? Of points. One distance. Okay? One distance. We're just in units, right? We don't have any like actual units. We're just calling it a unit, okay? One distance from 2, comma 2. That is it. That's all we drew. That's the entire picture. Okay, that's it. All we did was pick through 2 and then pick every point away from it, 2, 2. 1 with a radius of 1, right? And you could have seen if you were radius with 1, right? Okay, now, on the same graph, draw a circle, so that's down here. On the same graph, draw a circle with center 3, comma 2 and radius 2. Okay, so let's find 3, comma 2. Okay, and I will move this conjecture over here. Okay, if you guys are taking notes, I'm sorry for you, those of you writing in pen. You know who you are. Okay, let's see. Erase this right here. Well, let's see. So this one right here. Okay. Now let's draw this next one in orange. Okay, we're going to do this next one in orange. So first of all, I'm counting 1, 2, 3 in my x direction, and then 1, 2 in my y direction. So 1, 2. This will be my center right here of the orange circle. Okay. Now I'm going to pick all the points that are 2 away. It's a radius of 2. Okay. So I'm going to come over here. Let's see. 1, 2. This is a point, this orange point. Okay. 1, 2. There's a point, this orange point. And then another one. 1, 2. Radius of 2. Okay. 1, 2. Oh, we have to go up the page a little. That's okay, right? There's 1. There's about 2, right? That's fine. Just to get the idea. Now I'm going to draw another big circle. This is going to take me even more tries, right? Oh, my lord. If you guys get this on your first try, send me a picture. I don't believe you. Okay, I just don't believe you. All right, now here we go. Right here. Okay. Look at that. So this big orange circle is this guy down here. Maybe we'll highlight it. We'll highlight it. This is orange down here. Okay. I think that's yellow, actually. Maybe this is orange. I think that's orange. Could be pink. Don't know. Okay. Up here is blue. Okay. Don't blame me for being colorblind. So this one right here, this blue guy is right here, and this orange guy is right here. Okay. So it's pretty straightforward, right? Find your radius. Okay. Actually, let's. This is the next step, right? All we need to find our circle is 1. We need a radius. Okay. And 2, we need a. Oh my gosh. I'm so sorry. We should pick the center point first, right? But that is true. All we need is a center and a radius. All we need is a center and a radius. That is it. That is all we need. And you can draw a graph of a circle, okay? Math agrees. Math agrees, okay? So the center from the edge to the from the center to the edge of a circle is r, the radius. Okay, that seems pretty straightforward. I think we all do that. Okay. How can we calculate the radius? Okay, how can we calculate the radius? So this right here is the radius of the circle, right? Okay, this right here is the radius of the circle. This is the x distance you are, and this is the y distance you are, right? So, for any x and y, how can we find the radius r? Okay, here's what we're going to do. We're going to use Pythagorean theorem, okay? We know that x squared plus y squared is equal to r squared by Pythagorean theorem. Okay? Actually, and maybe first I'll write my formula down just so that we're on the same page. Okay, let's write it like this instead. C squared is equal to a squared plus b squared. That's Pythagorean theorem. Okay, we all know and love Pythagoras, right? My pen just gave out on me. I don't know what happened there. Let me erase that. It's kind of ugly. Okay. Pythagorean theorem. Okay, that's the Pythagorean theorem. The next step, my r is my c. My r is my longest side, so r squared goes right there. All right, and then x is my a, and then b is my y, and we can switch those if we need to. Ooh, I wrote b twice. Let me do that. Okay. Now, here's what this is saying. Okay, here's what this is saying, and let me just pull this up to be extra sure so that I don't put the wrong thing down. But basically, all we're saying is this graph is picking. It's picking a collection of points. If I come up here to my circle, we're picking a collection of points that meet a criteria. And the criteria will be our equation. So we won't write a function, okay? And this is going to trip us. A lot of this is going to trip a lot of us up because we're going to be trying to put it on a calculator, and it's really going to mess us up, okay? Oops, I clicked the wrong one, okay? Here's the big deal. The big deal is this, okay? I'm about to write, I promise. I'm just trying to pull it up on my computer, okay? So here it is right here. This tells the graph literally, check x and y and keep only those who are the right distance away, who are let's see, who are 4 away. Okay. If we're talking about 4 in this case, right? Okay. So here's what we're saying. Here's what we're saying. What we can say here. All of the ordered pairs, let's say this, all of the ordered pairs xy that satisfy the equation, okay? All of the ordered pairs xy that satisfies the equation. This is an equation. This is an equation, not a function, but an equation that literally creates the circle. Okay, literally creates the circle. It makes it. This fabricates the circle. It is constructed from the circle. Does this make sense? Okay, look at what's happening. Look at what's happening right here. Okay, this equation right here for the circle. Okay, this is saying get all of the ordered pairs x and y that make this true. Okay, now, what if I want my center to move? What if I want my center to be at 2, 2, like we did on the first problem, right? Because this only works for circles that are centered at 0, okay? How can I change that for my next equation? Okay, so we're going to talk about. We're going to do, let's see if this will pull up on the iPad. I don't think it's going to want to, okay? This guy, if you go to your browser and you type this guy in, it'll take you to an activity that'll show you exactly what I'm doing, okay? Take you to an activity that'll show you exactly what I'm doing on GeoGebra, okay? You can like click and move stuff around to see what's happening, okay? All we're basically going to get is we're going to get this, okay? For your center HK, okay? Let me say this. For the center HK, okay? This is the center you want. You want it to be. This is your X and your Y coordinate, okay? Here's what you want. For your center HK, the circle is X minus H. It's the opposite of H, okay? Plus, all squared, right? Plus Y minus K, all squared, okay? Equals R squared, okay? So you see our Pythagorean theorem in here, right? Here's my X term. Here's my Y term. Here's my R term, okay? So these guys still have to add to R squared, but now I'm subtracting, I'm moving them over before I actually start making my points, okay? So together we can graph these equations, okay? This first one, let's see. This first one, all we're going to do is we're just going to see. So this side, it says 2, and this side says -1, okay? So my my HK, let's write this down. My center, I'm always going to find my center first. My center is the opposite of these guys. It's a -2, 1, okay? My radius is 4, okay? Because it's 4 squared, okay? So now, if I come down here and I make a circle, or I make a graph, I mean, my center is -2, 1. Okay, there's my center right there. -2, 1. All right. Now I'm going to go 4 away. 1, 2, 3, 4. There's a point. Okay. 1, 2, 3, 4. There's a point. Okay. 1, 2, 3, 4. Just like this. 1, 2, 3, 4. Okay, you guys see this? This is going to be my circle. Okay, this is going to be where my circle is. It's just like this. I know this is an ugly graph, but same thing. This is all I want you guys to draw, okay? This is all I want you guys to draw. Here's your center, and here's your radius. And as long as you write this down, I know what your picture's supposed to look like, right? Okay, now I come over to this guy, and I'm like, whoa. I'm like, whoa. This doesn't look like what it looks like. This doesn't look like what it's supposed to look like. Oh, yeah? You think it doesn't? All right, well, I'm going to do a trick. I'm going to multiply everything here by 4. Okay, why am I doing this? Ask yourself, why am I doing this? I'm going to multiply both sides by 4. What's going to happen? I'm going to distribute this guy in. Okay, so I get 4 times 1/4 is 1 right here on the first step, right? Oh, that's just x minus 3 squared. Okay, plus. And then right here, 4 times 1/4, that's 1. Oh, that's why I picked it, right? I picked it so that these guys would cancel. I won't have to deal with them, okay? Plus 2 equals, and then here we'll get 4 squared, okay? 4 squared. Now, I can write y plus 2 times y plus 2 as y plus 2 squared, okay? Is equal to 4 squared. Now, I'm going to write down, I'm looking for my center. So my center, I'm going to write down my first step, okay? I'm in a form, this should be squared, right? I'm in a form that makes sense. Now I can see what my circle is supposed to look like. I've put it into this form, right? I've made it look like that. So now I know what I'm seeing. So now I can find my center. I know it's at the flip of -3, so the opposite of -3, and then the opposite of 2, which is -2, okay? And then my radius, and make sure this number is squared, okay? Make sure your number is squared because of Pythagorean theorem, right? I'm going to get 4 for my radius. Not 16, right, but 4. So it should look similar to my last circle, kind of, okay? I'm going to have, now instead I'm just going 1, 2, 3 to the left, and then I'm going, excuse me, I'm sorry, to the right. It should be +3, right? 1, 2, 3 to the right, and then down 2, okay? And now I'm going a radius of 4, so 1, 2, 3 right here, and then this will be 4, okay? So there's my first point, right? That's a radius of 4, okay? Then 1, 2, 3, 4, so that's a radius of 4. 1, 2, 3, 4, that's a radius of 4. 1, 2, 3, 4, okay? Not that bad, right? Radius of 4 in all directions. And there's my circle, okay? This is the circle that is created by the graph. Now I have all the ordered pairs that satisfy this solution, okay? And it's really that easy, guys. It's really, really that easy. Tomorrow we're going to talk about equations that don't look like everything else, okay? So if you want to think about that, I implore you to. I think you would love to try figuring this out. It's a really, really fun puzzle to think about, okay? So, but tomorrow that's what we're going to talk about, all right? You guys get started. You guys on, let's see, this will be on Wednesday.